Okay, so what are the key issues? Like you can see from the screen, key issues: material balance and will the operations fit on the site? A lot of the sites are generally fairly constrained in area, so that's a key consideration. In terms of water management, and there's two parts to that: water and leachate, and odour. Can we get to the outcomes? And they're quite well defined under the legislation with and the policy in certainly in New South Wales with odour units and and the ways to model and make the predictions on the odour assessment criteria. So look, of course, there's other key considerations: noise, power coming into the site if you need power. Ecology can be quite significant sometimes depending on the site, and look, traffic as well. And look, there can be others, of course. In terms of our approach, look, these are some of the general ideas in terms of, obviously, not just us, anyone that's involved in gaining approval wants to maximise the chance of getting the approval. Efficient solutions that can be implemented on the ground, and in terms of the interrelationships, and that's probably the key focus of this presentation, is what are those interrelationships and how they can affect particularly the layout and the controls that are put in place to get to the outcomes. Look, some of the projects we've been lucky enough to work on, Bega, down with Merimbula, where it's a FOGO operation, 5,000 tonnes per annum and a mobile air floor, and that was approved in August of last year and is operational. Remondis, and again we're lucky to work with that, and on that project where we expanded the approval from, I think it was 30 to 45,000 tonnes, aerated tunnels and MAF, and then in terms of Cleanaway, we worked on that with down at Howlong, just not too far from Albury, and 22,000 tonnes, aerated bunkers with, they had gore covers. Now you'll see there it was approved but not proceeding. I understand the council rescinded the lease on the site after the approval went through, but otherwise it would have been up and running. And on that, I'll hand over now to my colleague Rod, and he'll go through material balance and site layout.
Right, hi everyone. So now we're just going to talk more specifically about a couple of the key technical considerations that we've been involved with for composting approvals. So the first one is material balance combined with a site layout and land take. So this is an actual regulatory requirement that we've encountered on one of the projects we worked on, and really one key aspect of this requirement, as I read it, is just simply, do you have enough space? Can you actually fit in all the facilities you need to provide for your proposed processing rate? Now, this is obviously a very oversimplified site layout for a fictional site, but when we think about all the different elements of a site that might influence how much space you need and what your processing rate can be, there's many different things to think about, and many of them may be the governing factor for you. You need to think of the rate of material that's coming in, the density of that material. You then need to consider how much you've already got in an incoming stockpile that you might have. You need to think about what's the geometry of when you put material in that stockpile. Are the side slopes going to be steep so that you can store more, or will they be relatively flat so you can't store that much at all? What's the capacity of your composting? Say, for example, the early stage of your composting. You know, how big are your windrows if that's your type of composting? And how dense is the material going to be in there, and therefore how much can you store and process on that stage? And then maybe you need to then store product once you've finished in a stockpile at the end. How much space do you have to do that? Could there be an issue with you not being able to get rid of enough material at one particular stage? So maybe that's your governing thing. Long story short, there's a number of potential things that could be the governing constraint for the amount that you can process. So in this simplified example, for example, you could see in this site at this particular stage, the early stage composting is full, putting through as much material as it can at that stage. So as more material comes in, it's building up in the incoming stockpile. Or maybe another slightly less likely circumstance is that maybe you don't quite have the demand at this point in time. So your material's building up in your final stockpile area at the end there and can't get out. And so therefore the area that you've got for that final material might be the governing governing thing in this circumstance. So the way that we, for some projects, have quantified these different constraints to estimate the capacity and the area required is through a material balance. I won't go into the technical details too much, but pretty much we look at the balance of material at every time step, which might be monthly or seasonally, and we look at it at every one of those different points in the process before. And really, so you're balancing what your volume is at that stage in the process for that time step. And then you know your volume of material, and as we said before, then we look at what's the geometry of the stockpiles going to be, what's the geometry of any windrows going to be, and therefore, for that volume of material, how much space do you need at each one of those stages in the process. And then you can combine that volume with the geometry to get the required land take. Okay, so in a similar vein, another technical consideration that we have quantified is with relation to water balance. So often composting sites are imposed with a design rainfall criteria. That is, you need to manage and capture runoff that could be considered leachate for a certain design storm, 200 millimetres, 300 millimetres, 100 millimetres, whatever, some particular design storm. But that doesn't necessarily indicate how exactly is the site going to perform during periods of heavy or rainfall or dry periods. For example, if we look at an extreme example where you have a very large site, you've got a large catchment, you've got no sewer disposal, and you've got a low demand for reuse. In that case, then, in that particular case, then even if you had a very big dam where you could capture a lot of runoff, you mightn't be able to actually get rid of that water. So even though you've collected all that water, you don't actually know whether you can get rid of it. And even with a very large dam, you may end up overflowing all the time because there's simply nothing to do with all this water that you've now captured. And likewise, similar to a material balance, we just look at each time step. How much water is in the dam at the previous time step? What's the runoff coming in at the next time step? What's the reuse out in the composting process, for example? And therefore, rather than just saying the dam can capture 200 millimetres of rain, it's the dam will actually likely perform like this in real life situation. One key thing to note with material and water balance is that it's not some magical tool that if you know nothing about the site, you'll be able to come and do a few calculations and all of a sudden you'll understand your site intricately. You need to have an understanding of how the site operates. What sort of demands for water are there? What is the density of the material that normally comes in? What's the moisture of the material that comes in? So it's not something that's going to come along and answer all of the unknown questions you have about a site, but it is something that if you do have some knowledge about the site, can be used to quantify and provide some level of assurance to regulatory bodies about that you actually have looked in and calculated and justified how you think your site is actually going to operate in the future. And that can be very helpful in seeking approval. So now Evan's going to talk further.
Thanks, Rod. Just want to say that at GHD we don't do all of our figures in MS Paint, but I'm now going to talk about key issues to consider for odour assessments of composting facilities, and I'm going to quickly discuss sources of odour, composting techniques and odour control, odour sampling, and odour modelling. So on this slide here on the left, I've got the key sources of odour we generally include in our assessments and in our odour models. And on the right there, I've got a table which has the indicative odour contributions from the total site. So I guess the key take-homes from this slide is that the receivables area can account for up to 25% of all odour emissions. So it's imperative not to let the waste received in that area build up too much. We can also see that shredding can account for 18% of all emissions on site. Shredding, though, is often only undertaken for a short period of time and during the daytime period. As you can see, the active composting stage, in this example, it goes over 4 weeks, but it can sometimes go up to 8 weeks. In this example, it accounts for over 20% of all emissions, and generally this is where we like to focus odour mitigation. One thing I wanted to say, in New South Wales we need to do a cumulative odour assessment. So if the facility happens to be on a landfill, like most of them, we also need to consider the tip face, landfill gas and leachate, for example. Just going to go through some of the composting techniques and odour control that we often come across in the jobs that we do. The first photo there is just a traditional open windrow, and as you can see it's not enclosed, it's open to the elements. And one thing with this method, we don't really have much control over the factors which influence the composting process, such as temperature, aeration, moisture, and also wind stripping, which can lead to odour. The second photo there is an enclosed tunnel, so it's pretty much just a concrete bunker where the compost is placed in. As it's enclosed, we've got a lot of control over elements such as the moisture content, the aeration, the temperature, and the good thing about this is that any odour emissions can be emitted through an odour control unit such as a biofilter. The third photo there is aerated static pad. This is basically a collection of pipes which go beneath the windrows and introduce air into the system, so this can reduce the composting time, and overall it reduces the total odour contribution. But one thing to be mindful of is that when the aeration is occurring, we can get short-term peaks or increases in odour. The last one is just gore covers, which reduces the odour and can control the moisture content. Now the solution that you use really depends on the site, how much space you have, what the odour reductions needed are, what the budget is, and what the throughputs are at the site. Okay, so 6 or 7 years ago when we started getting involved in some of these larger composting projects, it became apparent that many of the reports that were out there had really low odour levels for a lot of these processes, and consequently the assessments were predicting really low impacts, and this was even from existing sites that had known odour issues and were getting odour complaints. So from this we realised we need to focus more on the odour sampling program in order to provide a robust assessment. So I just wanted to go through some of the key things we need to consider when we are doing the odour sampling. So the first thing is always get enough samples to ensure what you're using in the assessment is representative. Secondly, make sure you get the samples in the correct locations. Use the latest research and the science. So in that figure on the right there, we've got a cross-section of a covered maturation windrow, and I'm not sure if you can see the numbers, but most of the odour, or the highest odour concentrations, are on the crest of the windrow, and on the batters we're getting really, really low results. So I guess it's quite obvious what to do. You need to take the odour samples on top of the windrow. Another thing to be mindful of is that the isolation flux chamber, which is the standard method of odour measurement in New South Wales, it can underpredict odour concentrations by up to 100% in some situations. Common mistakes we see is just the use of an IFC, which is really small, to get a representative sample on a really large area source. So I just want to say, when you take an odour sample, make sure you use the right methodology. It doesn't always have to be IFC, so we can take up and downwind measurements. We can do a windrow splice and other methods. Just going to really quickly go through the odour modelling. Key issues that we need to consider is that the weather data used is representative, so it's always best to use a site-based weather station. The modelling software is suitable. Not all of the softwares available are to be used when there's complex terrain. Make sure the model is set up to represent each stage of the composting operations, and if needed, add in the cumulative sources. And we need to look at how the odour emissions change throughout the day. So the daytime emissions can be different to the nighttime emissions, for example. Lastly, we need to make sure that predictions are sensible and not contradictory to experience. So If you've got an existing site and you're on the boundary and you can smell odour and your model's saying there's no odour, you've got some issues.
Look, I'll just quickly sort of do a bit of a summary and if we've got any questions we can go from there. So, look, ultimately what we're trying to achieve is going about the process where you can quantify the outcomes, and the agencies are going through it and saying, okay, these are the outcomes we want to see these projects achieve. We go through a process of demonstrating using these methods that we've talked about to achieve the outcomes. Now, look, I'm just sort of reiterating, we've talked about the site layout, water management, leachate management, in terms of odour being representative, and what we do, and that's why we sort of came in as a team. In our approach, we knit together the group and we iterate through the process and make sure it all sort of comes together so each of the studies can demonstrate that it's consistent and we can get to the outcomes and it can fit on site. And look, on some of those occasions, what we come out of the end isn't quite what the client anticipated at the start of the process. But that's how we've been going about it, and we've been successful to date. So with that, that's a wrap. Thanks.
Thank you.